Welcome back. Let's answer a few questions given this diagram here. So the first question we're asked is, we want to give two possible names for the ray in this diagram. So we want to find a ray in this diagram, and we want to give two possible names for it. So what does a ray look like? A ray has one endpoint that extends infinitely in one direction. And here we have a ray. U is an endpoint, and it extends infinitely in this direction. And this is actually the only ray in this picture here. And we want to give two possible names for it. Well, the first name is UV. UV. We start with U because that's actually the endpoint. We always start a ray with the endpoint. And here it's U, so UV extends infinitely in this direction. We can also name it US. U is an endpoint, and S is some point on this line. Now notice there's an infinite number of points on this ray here, so we can call it an infinite number of ways. But since we're only given 2 points other than the endpoint, we can only name it two possible ways. So UV is one, and US is another name for this ray. All right, let's take a look at the next one. Let's say we want to give four possible names for the line in this diagram. All right, so we want to find a line in the diagram above and give four possible names for it. Now, what does a line look like? A line consists of two or more points, two or more collinear points, which means if we have two collinear points, we can draw a straight line and it'll connect both points. And the line goes infinitely in both directions. Now, here is a line. The points R, S, T are collinear because all 3 points are connected with one straight line. So we want to give four possible names for this. One name is RS. These are 2 points on the line. So the line RS has 2 arrows because it extends in both directions. Another name is ST. These are 2 more points that are on that line. So the line ST. We can also call it RST using all 3 points. And we can also call it RT. So the line RT. Now, is this all their names for it? No, absolutely not. You can also flip these. The order, since the order doesn't matter, we're not talking about direction, we're not concerned with it. We can call it SR. We can call it line TS. We can call it line TSR. And so on. So there's a lot of different ways you can actually describe this line, but they all mean the same thing, which is very cool. All right, let's take a look at the next one. We want to find an acute angle. An acute angle. Now let's get a quick refresher. What does an acute angle mean? An acute angle is an angle that has a measure between 0 and 90 degrees. Now, it's not including 0 and 90 degrees. If it has an angle of 0 degrees, well, then we don't have any angle. If it's a 90-degree angle, that's a special angle called a right angle. So an acute angle is an angle with a measure between 0 and 90 degrees. So we want to find an acute angle up here. And here's one right here. We have TSV. This angle right here is an acute angle. It's an angle smaller than a 90-degree angle. All right, so angle TSV is an acute angle. We always want to label the vertex right in the middle. We wouldn't call this STV or VTS. This is TSV, can also be called VST. But we want to have its vertex in the middle. All right, very, very important. So that's an acute angle. Let's find ourselves an obtuse angle. We want to find an obtuse angle in the diagram above. Now let's remind ourselves what an obtuse angle is comprised of. An obtuse angle is an angle that has a measure between 90 degrees and 180 degrees. Now that's not including 90 and 180. 90-degree angle is, like we said before, a right angle. 180-degree angle is called a straight angle, which we'll talk about actually in a second. So we want to find an angle that is greater than 90 degrees, but less than 180 degrees. And here's actually an obtuse angle right here. UST is an angle greater than 90 degrees. So angle UST, or TSU, however you want to look at it, is an obtuse angle. We also have another one here, RSV, that's also an obtuse angle. Okay, Let's take a look at the next one. Next one we want to find a straight angle. Now a straight angle is another special angle, just like a right angle, but a straight angle is an angle that has a measure of exactly 180 degrees. Now these are very simple to find. A straight angle just looks like a straight line. And we know from up here that we have a line RST, so this angle right here is a straight angle. This angle RST. So angle RST is a straight angle. We also have another straight angle right here at USV. That's also an angle that has a measure of 180 degrees. All right, let's take a look at the next question. We want to find an angle that can be named using only one letter. So this is very important, and we haven't touched on this yet, but if there's more than one angle at a given vertex, then we have to use 3 letters for it. If there's only one angle at a vertex, like in U, this vertex right here describes this angle SUR. We can call this angle U. Angle U. We can describe it with one letter because it's the vertex of only one angle. If we call this, let's say we're talking about this angle right here. If we call this angle S, we can't do that because S is ambiguous. What I mean by that is if we're talking about angle S, we can be talking about this angle, we can be talking about this angle or this angle. We can actually, S is the vertex of 4 different angles, so we can't call any of these 4 angles angle S. We have to use 3 letters. U, we can call this angle just using angle U because it's the vertex of only one angle. All right, so very important, so we know exactly what we're talking about. All right, let's move on to the next one. All right, here we want to talk about something called the angle addition postulate. Now, the angle addition postulate might sound very familiar to the one in the previous section when we talked about the segment addition postulate, and it works pretty much the same, except here we're talking about angles. So let's say we're given the following information. So we have this angle here, this angle here, this line or this ray extends. We have 3 rays here. And this is going to be called, we have a point here, and a point here. This is point A, this is point B, this is point C, and this is point D. So we have 3 rays coming out of point D. All right, and we're given the following information. We're given the measure of angle ADC is equal to 100 degrees. And we're also given the measure of angle ADB equals 40 degrees. We want to know what the measure of angle BDC is. Okay, here we can actually use something called the angle addition postulate. Now, if you recall when we talked about the segment addition postulate, when we had a segment, we can actually find the total angle, the large segment, by the sum of the 2 smaller segments. Well, here we can actually find the sum of the large angle by adding the 2 smaller angles. All right, so it works much the same way. We're just dealing with we're dealing with angles here instead of segments. So we know that angle ADC, which is this big angle right here, is 180 degrees. We also know that angle ADB, which is this angle right here, is 40 degrees. So we want to know what this angle right here is. This angle right here. So how do we do that? Well, the angle addition postulate says that if we add these 2 angles here, we can get this larger angle. So we can say that the measure of angle ADB plus the measure of angle BDC equals the measure of angle ADC. All right, very similar to the segment addition postulate. This is called the angle addition postulate. So all we simply do is use this information and plug it in here to find what we're looking for. So ADB is 40 degrees. So we have 40 plus BDC is actually what we're looking for, so let's go ahead and call this x. So 40 plus x equals the measure of angle ADC, which is 100 degrees. And we should be able to simply solve this. Let's subtract 40 from both sides. Solving for x, these two cancel. That leaves us with x is equal to 100 minus 40 is 60. So the measure of angle BDC is 60 degrees. All right, this is called the angle addition postulate. And it's very important that we get this down because we'll be using this quite extensively throughout actually all of this course in geometry. So be sure we get this down very, very, very good. All right, so look over this this video in a few more times, and we're just using rays and angles right here. The next section we'll be talking about segments and angles, but be sure you understand the angle addition postulate before we move on. So I'll see you soon.